Have you ever looked through a window and wondered what it's really made of? It's perfectly clear, smooth, and solid. Now think about sand at the beach. It's grainy, rough, and you can pick up a handful of it. What if I told you that the clear window and the gritty sand are almost the same thing? How is it possible to turn something so ordinary into a material that is so important to our world? Look around you right now. You are probably surrounded by glass. It's in the screen of your phone, the light bulbs in your ceiling, and the cups in your kitchen. Glass is one of the most useful materials we have ever created. It lets light in, but keeps the wind and rain out. But the journey from a pile of sand to a pane of glass isn't simple. It involves a hidden and powerful transformation. The biggest challenge is that sand doesn't want to change. It's a very stable and hard material. Each grain is a tiny, strong crystal. You can't just press them together to make a window. So how do engineers and scientists convince these tiny crystals to become something entirely new? The secret isn't a magical spell. It's something much more powerful: extreme heat. The main ingredient for glass is a special kind of sand called silica sand. It's made of a compound called silicon dioxide. Think of each grain of sand as a tiny, perfectly organized building made of silicon and oxygen atoms. To turn this into glass, you need to melt it. But sand has an incredibly high melting point, over 1700 degrees Celsius. That's 3 times hotter than the inside of a volcano's lava flow, and much hotter than any oven in your kitchen. Inside a giant furnace, the sand is heated until it begins to glow, turning into a thick, fiery liquid. When it melts, that organized crystal structure of the sand completely breaks apart. The atoms start to flow freely, like a jumbled crowd. But melting pure sand is difficult and expensive. So glassmakers add a few secret ingredients to make the process easier. The first is called soda ash. You can think of it as a helper that lowers the sand's melting temperature. By adding soda ash, factories don't need to use as much energy, which makes the whole process more efficient. But this creates a new problem. Glass made with only sand and soda ash would actually dissolve in water over time. To fix this, a third ingredient is added: limestone. This acts as a stabilizer. Limestone makes the final glass strong, durable, and resistant to water, so your windows won't wash away in the rain. So the basic recipe for most glass is sand, soda ash, and limestone. Often, another ingredient is mixed in: old, recycled glass. This is called cullet. Cullet is fantastic because it melts at a lower temperature than the sand, helping the entire batch melt faster and saving even more energy. Once this mixture is a glowing molten liquid that looks like thick honey, it's ready to be shaped. To make the flat sheets of glass used for windows, engineers use a clever method called the float glass process. The molten glass is carefully poured onto a bed of perfectly smooth, molten tin. Because the liquid glass is lighter than the liquid tin, it floats on top. Gravity pulls it down, making it perfectly flat and smooth on both sides. For things like bottles or jars, a different method is used. A blob of molten glass is placed in a mold, and then air is blown inside. This inflates the glass, pushing it against the sides of the mold to create the hollow shape, just like a small balloon. After the glass is shaped, it enters the most critical stage of its journey: cooling down. If you cool glass too quickly, it becomes incredibly brittle and can shatter from the tiniest stress. So the newly formed glass must travel through a long oven called a layer, which cools it down very, very slowly. This process, called annealing, relieves all the stress inside the glass, making it strong and stable. So what is the big insight here? Glass isn't just melted sand. It's something completely new. Sand has a neat, ordered crystal structure, but when we melt it and cool it down quickly, the atoms don't have time to get back into their perfect order. They are frozen in a jumbled, disordered state. Glass is a solid, but its atoms are arranged like a liquid, This is the amazing power of science. It allows us to understand the hidden structure of materials and change them. We can take something as common as sand and, by rearranging its atoms, turn it into the transparent world all around us.